Hello and welcome to my channel. This is Dr. Tidman. Thank you for taking the time to view this video, which is a short research review presentation. This presentation will outline my interpretation of the elements, study design, and results of the study I'm reviewing. I will also post the original study article in the description so you can read it for yourself. Please remember to like, subscribe, and hit the notification bell so you're not going to miss any of my future videos. I typically post new videos every Monday. Please remember that these presentations are for informational and educational purposes only. Please contact your medical team before making any changes. My background is that I am a metabolic health practitioner, a professor, and the director of clinical research for the Colorado Parkinson'S Foundation. Since 2018, I have been conducting clinical research in Parkinson's disease. Some of my former video presentations are available on my channel. I've also posted some presentations on gut health and general health improvements, osteoporosis, metabolic syndrome, and other health-related topics. I invite you to review them and comment if you find them useful or educational, or if you have any questions. Today I will be briefly reviewing a research study entitled Neuroprotective Effect of a Medium-Chain Triglyceride Ketogenic Diet on Gut Microbiota in Parkinson's Disease Mice by Zhang et al. So many of you who have followed these research reviews are probably wondering, why is Dr. Tidman, a clinical research in human health, doing a review of a mouse study? What a great question. Let me first share some thoughts on the importance of research using mouse models in Parkinson's disease. Some of the benefits of first conducting mouse model studies include studying the basic mechanisms of neurodegeneration. Animal models can help researchers understand the cellular and molecular pathways involved in dopamine neuron loss, which is one of the hallmarks of Parkinson's disease. Toxin-based models and genetic models mimic some of the pathological features of Parkinson's. Drug screening and preclinical testing can be done in mouse models where they necessarily wouldn't be ethical to test on humans. Rodents and non-human primates can help assess the safety and efficacy of potential medication treatments in Parkinson's. Animal studies are still a required step before human clinical trials to comply with regulatory guidelines. Researchers use mouse models to investigate things like neuroinflammation and protein aggregation in the brain. Using animal models, researchers can also evaluate surgical and gene therapy approaches. Even procedures like deep brain stimulation were initially tested in animal models to determine their safety. So I hope this provides some context. As a metabolic health practitioner, my focus is always on providing some practical applications to your daily life. So at the end of this research review, I will highlight some of my practical tips based on the study and on my years of experience in metabolic health. Now, on to our study. Remember that this information is for educational or informational purposes only. Please consult your medical team if you want to make any changes. So the objectives of this review are to first review the study and the study design, review the variables and interventions that the researchers tested, review the results of the study, review the conclusions by the authors, and then present Dr. Tidman's tips and takeaways at the end of the review. So the ketogenic diet is a low carbohydrate, high fat, moderate protein diet. Research has shown that the ketogenic diet plays a protective role in neurodegenerative diseases by elevating ketone bodies in the bloodstream in the form of beta-hydroxybutyrate. We know that ketones can help regulate central and peripheral metabolism and mitochondrial function, serving as an energy source. We've also seen in other studies that ketones inhibit neuroinflammation and oxidative stress in the brain. And we've also reviewed research where ketones can alter the gut microbiota with some positive effects. So the author, Zhang et al., examine the possible protective effects of medium-chain triglycerides in a mouse model where the mice had been altered to simulate Parkinson's disease. They examined the mouse gut microbiota and its metabolites and evaluated the substantia nigra region, which is where Parkinson's is most evident. We know that long-term MCT or ketogenic diets significantly reduce damage to those neurons that produce dopamine. So this is a very promising finding. We know that antioxidants are helpful in reversing oxidative stress in those neurons that produce dopamine, and ketones have an antioxidant effect in the brain. They also found that the use of MCTs or the ketogenic diet reduced the loss of certain mitochondria in the brain. And we know that mitochondria are important because they generate energy. They also found that elevation in ketones produced a protective response for those dopamine-producing neurons. And they found that gut microbiota were improved due to the elevation of ketones, and that this gut microbiota communicates with the substantia nigra neurons in the brain via the vagus nerve. So there's definitely a gut-brain connection that they discovered. They also discovered that use of the ketogenic diet and MCTs increased the abundance and variety of gut microbiota. And this was interesting because this is one of the criticisms that I have read about, that the ketogenic diet will actually impair your gut microbiota. But their finding was that it actually increased the variety of gut microbiota. So the authors found that an MCT ketogenic diet has produced multiple protective effects in Parkinson's disease. They cited that there's an increasing number of studies that have shown that MCTs, medium-chain triglycerides, have a protective effect and can often impact the progression of neurodegenerative changes in Alzheimer's, Parkinson's, epilepsy, and stroke in some cases. Ketone bodies in the form of beta-hydroxybutyrate are a natural alternative fuel source for the brain. Ketone bodies also improve mitochondrial metabolism and reduce oxidative stress. Medium chain triglycerides, both the oil and within a ketogenic diet, can produce elevations in blood ketones and reduce the adverse effects of fat adaptation, which is a period that it takes the body a little while, different for everyone, to adopt a fat burning preference rather than a glucose burning preference, which most of us have lived with more of a glucose burning as a fuel source for many years. They also found that MCTs and the ketogenic diet produce ketones that can cross the blood-brain barrier and act as an energy source. As we've discussed, the ketones can alter the gut microbiota. And through a lot of research that I've even reviewed on my channel, we've discovered that gut microbiota can also produce ketones themselves and neurotransmitters that are needed for brain chemistry. The gut can actually communicate with the area called the substantia nigra in the brain, indicating that the effects of a ketogenic diet and the use of MCTs has great potential for protecting the brain. And of course, we've seen research coming out of NASA by Dom D'Agostino's group that ketones do have a neuroprotective effects. And of course, we've known that for 100 years because the ketogenic diet has been used as an anti-epileptic in people with epilepsy. We know that ketones that are generated using a ketogenic diet or MCTs can actually slow the loss of dopamine producing neurons. Ketones can also reduce the loss of critical mitochondria, which is often seen in Parkinson's disease. So what are Dr. Tidman's tips and takeaways? Of course, you've seen these many times if you've watched others of my research reviews. Try implementing a low-carb ketogenic diet and add intermittent fasting. A fasting state elevates your blood ketone levels rather quickly. I would suggest you start with a 16-8 fast, which is basically 2 meals a day, where you fast overnight for 16 hours. You also can move then to a 1 meal a day approach 2 or 3 times a week, which is a 20-hour fast with a 4-hour eating window, or a 23-hour fast with a 1-hour eating window. I would suggest you reduce your carbohydrates to below 20 grams per day. Purchase a blood ketone and glucose meter to track your glucose and ketones. Research has shown that if you get your ketones up towards 1.0 millimoles or higher, that you can reap the most neuroprotective benefits. To elevate ketones, another method you can use is to add daily organic MCT oil between 3 and 5 tablespoons per day. Of course, you want to work up slowly so that you don't have any GI issues, but you're trying to elevate your ketones, and this is another way you can do that. This is the Zhang et al. Reference. And again, I'll post the research article in the description. Thank you for viewing this brief research review. Even though it reviewed a study that used a mouse model, there were many things that the researchers found that could be applicable to humans with Parkinson's disease. If you have any questions, you certainly are welcome to email me at melanietidman@gmail.com. And if you're interested in participating in one of my research studies in Parkinson's disease, you can email me at study@coparkinson.org. Remember to subscribe, like, and hit the notification bell so you'll be informed of my future video postings on my channel. Again, thanks for stopping in, and I'll see you in the next video.